quite a good job. Name's Martin Butler. I've held a full license in the UK and the US, 2 call signs, been licensed over 25 years, 17 years on the podcast. I only said I was doing 10. We've done over 470 of them now. And the boys say if I get one right, 10 right, I'd have finished. But there you go. Registered trainer of the RSGB as well. So that's a little something. Mike talked about our talk group. Oops, let's go back one. Oh, well, Mike talked about our talk group very quickly. If you've got digital radio, you can communicate with other types of radios, as you can see here. Natively D-Star won't talk to DMR or Fusion. Via our talk group bunch, we can do that. Another story, another time. Just for a bit of fun, I put this one in. But I think that sums all of us up quite nicely. We're wizards. We're geniuses. Let's go for it. Yeah. Okay. Now, this talk is, as I say, never do this one twice the same because there's always new things happening. Towards the end, there's 2 parts to this really. There's a bit about how to fault find and one thing and another, but towards the end there's a number of tips that you may wish to remember. I'll give Mike a copy of this presentation afterwards if he wants it, and you guys can obviously don't sit there with pens and paper trying to write it down. Okay, so fault finding. Well, I'm a practical person. I'm not a designer. I'm a fixer. I fix things because I can't help it. If something's dead, I've got to have a go at it. And I gained a lot of experience over the years in radio, TV, and the computer industry. And my latest project is I'm now part of a repair cafe in my local area where I go and fix all sorts of bits and pieces one Saturday a month. So passing on some of these tips to you. Now, this is the important one. Any advice I give you today is given in the spirit of amateur radio. You need to make sure you are comfortable with doing some of this. If you're not comfortable, if you're not electrical, then don't try anything that you don't feel safe to do. The most important thing is, I'd love to talk to you all again. I don't want half of you killing yourself doing something silly. Yeah? Okay. So fault finding. As I said here, it's often a state of mind. Now, I'm going to quote a story that must have happened to me about 1973. Yeah, I'm an old one, I know. I was working as a radio TV engineer for Comet, the big retailer at the time, went bust a few years ago. And I remember looking at my calls, and I had 2 particular calls. One looked very, very easy, and one looked very, very difficult. The easy one was a black and white telly, no sound. Well, I did those all the time, so I wasn't worried at all about that one. The other one was a colour TV with no colour. I have to tell you, when I got to the black and white TV, I couldn't fix it. And I had to bring it into the workshop, which was unusual. And it had a pig of a fault. Somewhere in the IF, I think, the fault was sound IF, killed it off. It just didn't receive any sound. The colour TV, I walked into the customer's house, he said, there's no colour on this TV. And I walked up to it, and in them days, you had a colour knob on the front. And I just turned the knob up. There was the colour. So what I'm saying is, often it's a state of mind. If you're beaten before you start, then don't start. The thing is, you've heard of keep it simple, stupid, KISS. Well, the other one is keep it kids, which is keep it difficult, stupid. I like to go with the KISS version rather than the kids version. Don't prejudge a problem. You know, if you prejudged it, you've failed pretty much because you've decided what the fault is without even investigating. So effectively what I'm saying is have an open mind for fault finding. That's what it's all about, open mind. Now, pair of eyes looking at you. Well, when you think about it, have a good look round. When you're fault finding, lots of faults can be found by just having a good look. Is there any physical damage? Has the customer dropped the thing? By the way, this talk is not limited to radio. It's a generic fault finding talk. So some of the things are radio, some are computer related. But anyway, they all bear they all bear relevance as we go through it. So is there any physical damage? Has it been dropped? Are there any burnt components? If the resistor's burnt out, yeah, that could give you a clue. Any stress components? Some components aren't totally dead or haven't burnt, but they look stressed. They sweat or change colour. So have a good look round. The other thing is, when you're looking at a piece of equipment, not everything, but some devices have an error log and they have error codes in it. Check the error log if you can. Now, young lad there, showing his ears. I learned a long time ago, listen to what the user is telling you. As I said, back in the 70s, I was a radio TV engineer, and you'd arrive at somebody's house and you'd say, what's the fault? And the customer would tell you what the fault was. Now, they couldn't explain the technical terms of electronics. They couldn't explain one thing or another. But if you let them tell you what was wrong with it and what went wrong and what was happening at the time, often you can piece together what the fault is quite quickly. So I'd say to them, did the device make any noises? Is there any arcing? TVs used to arc at times. The HD used to flash all over the place. Are hard disks spinning up and completing their diagnostics? Now, if you're fixing a computer, you might want to know if that hard disk has spun up into life. It's an easy way of doing it. And once again, because these disks are low voltage, you'll probably be okay. You can use a screwdriver as a stethoscope. Effectively put the screwdriver on top of the disk drive and put your ear against the screwdriver. You'll hear it power up, you'll hear it go for its diagnostics. If it's a faulty hard drive, you'll often hear it banging against the end stop where the thing's failing badly. But a little tip there, you can test hard drives. Are any motors working or making noises? Once again, when you switch things on, is there a hum or pops from the loudspeaker? If the thing's humming, you've got mains voltage to it or supply voltage to it, so you're in with a bit of a chance. Limit, you can obviously clear lots of ideas away straight away by just being thinking about it. Yeah, the lady says it smells. Yeah, having a sniff round will tell you. I remember having to do two days work in one day because I wanted the Saturday off when I was working for Comet, and they gave me my round and then they gave me another round to do in the evening and told the customers I'd come into them. I remember getting to Worthing at 12:30 at night, waking this woman up, going into the house, and she had a big 26-inch colour TV, and I knew what the problem was before I walked into her front room. The place stunk of rotten eggs, which was the EHD tripler had gone up in smoke. And I'd used my last one the time before. She weren't very happy with me, but at least I turned up and ordered the part. It was done the next day. What else can we? Yeah, keep a log of what you're doing. If you're rummaging around, have a look for a log. Is there a log? Has anybody done one? But keep a log of what you've done. That helps you later on. So are there any log files? Sometimes in piece of equipment, people put history cards in. Each engineer fills their little bit in and puts it in the back. So it's worth looking for seeing if somebody's put a bit of paper in the back. And it's not only tellies and one thing or another. I've come across some real old valve radios where engineers have put reports in what they've changed. And that gives you a clue sometimes to what's gone wrong in the past. So, yeah. So as I come almost full circle before we go off into the interesting stuff, fault finding is a state of mind. If you want to fix it and you have an open mind and you ask the right questions, you've got a fairly good chance of being able to do it. So, as I said, with the right attitude, right open mind, right attitude, you know, you're part way there. But once again, make sure you're comfortable of doing this. If somebody asking you to work on high voltage stuff and you don't feel comfortable working on high voltage stuff, or you don't feel safe, don't do it. You know, are spares available? That's another question you got to ask yourself. You know, I was asked the other day, a guy was asking me, if I bring my Grundig tape recorder to the repair cafe that's been sitting in the loft since 1980, do you think you can get it to work? And I said, well, the first thing you do is don't ever switch it on, mate, because it'll probably go up on the bomb like a bonfire. And I'll have a look at it for him when he brings it to the cafe. I don't think it's going to be cost effective to fix it, but we might do. Let's see how it goes. Is it worth repairing is the other thing. You know, I like to think yes, because even if I'm only saving myself a couple of pence, I've had the fun of fixing it. There's certainly a fun in fixing things in my book. So, man-made faults. Oh, they're horrible. Ask the person who's giving you, or if it's not yours, ask the person, has anybody else had a go at this? Because if somebody else has been in there before you, the chances are there's man-made faults, which makes it much harder to find because they don't obey logic. You know, they're much harder to find. As I said, they don't obey logic. So look for signs of previous repairs, you know, extra solder on printed circuit boards, different color capacitors, that sort of thing. Badly wired in components thing. And you can always ask your mates or somebody for a bit of help, but don't expect them to do the work for you. I was a member of another radio club, and I used to help a couple of guys, and suddenly found that they were going down the market buying computers at the boot sale, asking me to fix it for them and selling them at the next boot sale. And I thought, hang on a minute, this is a radio club. I want to be involved with the radio. I'll help you, but when you're using me to run your business, forget it. So there you go. So we will get on some pretty pictures in a minute. I know this is death by PowerPoint and lots of words at the moment, but circuits and manuals are available, or often available, on the internet. You don't have to buy them. And if you have a computer scanner, you can often scan parts of circuits and make the circuit bit you're interested in much larger. Now, little tip here, one I came across not so long ago. I was trying to fix a switch mode power supply for somebody, one of the members of the club, and it was a Watson power supply. So we put in Watson and its model number, and all I could get was pictures all over the place. I could only get pictures, no circuit diagram of what was wrong with this. A little tip for you, if you're repairing something, not everybody makes their own equipment. Lots of manufacturers badge engineer other manufacturers' equipment. And what you can do, if you open up a piece of equipment and you see a part number on a printed circuit board, search for the part number on the printed circuit board. That then may get you to the actual circuit. And in my instance, I searched for the part number, which showed me lots of pictures of this printed circuit board, but I then clicked on the Google images, and I think about the 10th image along was the circuit diagram for this thing. So My colleague at the club was very, very pleased because it cost him a £1.50 transistor to get a 25 amp power supply back up and working. So he was happy as pig. But that's a little secret, little suggestion. You know, look for the part number of the board that you're working on, and if you use Google Images, sometimes you'll find it there. If you can't find it a different way, sometimes there are stock faults. You know, when I was a TV engineer, you know, I used to do 12 calls a day. You know, only because 10 of them were probably going to be dead stock faults, dead easy. You know, you'd done that same fault, you'd seen it so many times. But sometimes there's stock faults. Sometimes there's stock faults in equipment, the components, the type of component that goes wrong. And I'll cover that a little bit later. But yeah. Now, high voltage. And this one I do need to labour. Remember, the fuse is fitted to protect the equipment, not you. A 13 amp fuse doesn't blow at 13 amps. It'll probably blow at about 16. But it'll, if you've got a dead short, it'll blow that fuse. But it'll be long since electrocuted. And if you've got your hands, one hand on earth and one hand on the mains, you're dead long before that fuse blows. So I'm not trying to frighten you, but be aware of that. So I often say to people, try and work one-handed. Now, I haven't checked to see if there's any ladies in the audience, but I'm still going to say it anyway. I tell people, when you're measuring with a multimeter or a scope, keep one hand in your pocket when you're poking around the board. Because if you get a shock between your forefinger and thumb, it hurts. And you'll be thrown back and whatever, but you don't get it through the heart. You don't want to get a shock. So I always say, keep one hand in your pocket, because it don't matter if people accuse you of playing pocket billiards, you're staying safe. Yeah? We've jumped back a couple of times, so just ignore that. Oh, the thing jumped on me. Okay. If possible, try and use an isolating transformer, current limiter, and a variac. Now, not everybody has those, but if you have, use them. And I'm going to show you a few bits and pieces and explain exactly what they are for those who may not know. So, come on, let's go to the next slide, please. And is my mouse playing up? No. Okay, current limiter. Well, there's a circuit for one. There's somebody's on bench there. Now, don't throw away incandescent light bulbs. When you switch over to your LED light bulbs, the incandescent light bulbs, what you do is you put one in series with the live. Now, in that circuit there, if I plugged a piece of mains equipment across it, if there was a short circuit on the radio or whatever, or I was testing, the bulb would light up absolutely bright, just like a normal day. But it would limit the current going into the device, so the device won't burn out. Once you're happy, what you do is you start off with the switch open like it is, S1 open. You make the connection. The bulb will glow because there will be current flowing, but it won't grow very bright, which you don't want it to. And then what happens is, once you're happy that there's not a short circuit, then you can switch S1 in and supply the full power. It's also a useful circuit. We used to use it when we were fixing television line output stages, and we used to reduce the voltage to the line output stage when we were fault finding it, because it used to blow the thyristors up straight away on full voltage. So little circuit like that, well worth its money. And I came across a rally in Ashford last year, and a lady was there giving these bulbs away. Now, I got a few under my stairs. They're very useful to keep for this. So don't throw any incandescent bulbs away, guys. They are useful. Right. Isolating transformers. Well, the idea of an isolating transformer is you want to isolate the secondary from earth. Now, you've still got current flowing, you can still get a shock, but it's not as bad as you getting a shock to earth injury. And they wire the earth, bypass the earth straight through to the socket on the secondary. No, that must be removed. There should be no connection to earth on the secondary side. Right. Variacs. Well, they're just variable transformers. They're not an isolating transformer. What they're used for is to bring mains voltage up slowly. So if you suspect you have a problem, a bit like the current limiter, they're a bit more expensive than the current limiter, but I'd still think they're worth having both. This you can bring up, you can set something, say, for 50 volts and leave it for a while, and some of the capacitors will reform themselves if it hasn't been on for years, and then you can bring it up a bit more and a bit more until you bring it up to the full voltage. But bring it, variacs, very useful. You may come across some of these things at rallies that people don't know what they're for, but if you get one, they're pretty good. I had a guy turn up at my house a good few years ago, and he said, "Martin, is this whole thing any good to you?" It's a 10 amp variac. "Yes, please. Thank you very much." Okay, check the rating of the device. You can't, if your variac will only do 3 amps, you can't put a kettle on it or something like that. But a 3 amp variac is perfectly good for things like radios and valve radios. Okay, divide and conquer. Simple radio circuit. We've all had this. We've all had this when we were doing our testing. But okay, you switch it on. It doesn't. The customer says it don't work. Well, first thing you do is check the batteries and the battery compartment and make sure it's not all leaked in there, obviously. But switch it on. Did you get a pop from the speaker? At this point in time, in my grubby hand, I haven't got a audio generator. But if I wet my finger on a battery set and I stick a screwdriver with my wet finger on the volume control, the audio should buzz. If it buzzes, I've pretty much written that the audio stage is okay. If I have another radio, I could tune into the oscillator, see if the local oscillator is running. But the idea with this type of fault finding is you break the circuit up. Do the easy bits first and then cut down through as you go. Divide and conquer is a way to do it. Now, simple test gear. Multimeters. Okay, I went through a stage where I fell in love with multimeters, and I had something like about 30 at one point in time. I've thinned them out now, but they are worth their weight in gold. You will find most people don't know how to use an analog multimeter. It's a lost art. We had a gentleman turn up at the club about a year ago, and he said, "I got this meter, it don't work, it's no good." Well, it was actually a Mark 1 AVO 8. It was actually an AVO 8, Mark 1, built about the same year I was born. All it needed was 2 batteries and a bit of cleaning up, but the thing's absolutely perfect. I know it's had a hard life, but he didn't know how to use it, so thing. Digital meters are great as well, but I think if you're doing a lot of work, you probably need both. Little power supply, well, I'll come on to that in a minute, but power supplies are worthwhile. Or, battery connector so you can connect. Audio generator, there's loads of little circuits for those around. And as I said, on low power stuff, you can wet your finger and touch the volume control or touch the input, and you'll hear a buzz, and you know it's pretty much working, or it's going to do something. RF generators, well, if you're going to fix radios, you probably want one. RF probes are things that you can connect to a multimeter to see if the multimeter, if an oscillator or something's running. Now, a multimeter normally works at very low frequencies, so much above, say, 200-300 hertz. It's not happy. So an RF probe effectively is a diode probe. You have a diode, it rectifies and smooths it and gives you a DC voltage. So you put it on an oscillator, the oscillator goes through the diode, and effectively you read a voltage. Simple audio amplifiers. Now, I'll show you one in a minute, but little amplifiers are well worth having in the shack or repair centre when you're doing them. And they're available quite cheaply if you make them, or often people, and at rallies, people are throwing out old computer speakers. They work just as well. Oscilloscopes. Lots of people panic about oscilloscopes. I have a presentation on oscilloscopes, haven't done it for a while, but effectively, you look at an oscilloscope, it's got lots of buttons and knobs and this, that, and the other. What does it really do? It measures voltage in the vertical direction against time in the across the screen. So volts up, time across the screen. It draws a graph for you. That's all it does. And just because somebody says, "Oh, I can't measure. I need a 30 megahertz scope, minimum of 30 megahertz scope to measure every signal on an HF radio." Well, if you've got a 20 meg scope or a 10 meg scope, you might not see everything, but often the frequency, the maximum frequency the scope works at is at its highest level. Outside of that, it's uncalibrated. So you won't be able to measure voltage outside the calibrating, but if you put your scope on it and you say, I've got a 30 meg scope and you put it on as a 45 meg signal, you'll probably see a very small 45 meg signal, but you'll see it's there. So oscilloscopes, yes, good ones are good, but you can pick some of the older analog scopes up for 10, 15 pounds these days at rallies, and they're quite useful. Capacitor dischargers, yeah. What all that it really is a high value wire wound resistor with two probes, and you really want to discharge for a resistor. Shorting them out, if shorting capacitors out doesn't do them a lot of good. They need not a slow discharge, but they need to be discharged properly. You want, if you've got a fault and you've got high voltage on a capacitor, you want to drain it off before you put your hands in. I've been caught many a time on that with a charged up capacitor still in the circuit with a fault. So, little simple power supply. I'm not suggesting you build one of these, but a little power supply, they're dead easy. There's often bits and pieces kicking around, and you can buy them converted online. Some people, there's enough YouTube videos showing you how to convert old computer power supplies. So you've got plus 12, plus 5, minus 5, minus 12. So yeah, there's loads of options you could do. And they can be built with discrete components and ICs. There's various ICs these days that do all the regulation for you as well. Now, that's what I was talking about, the RFAF signal probe. Basically, it's just converting AC on the probe into DC to feed into the multimeter. So that's the sort of thing we're talking about. This is a circuit with a little audio amplifier, excluding the speaker. Dead easy to make. Guys, you can buy a little board about twice the size of a postage stamp for about £1.50, and it'll be all of that minus the speaker. So, you know, it's not a difficult thing. I made a powered loudspeaker the other day to go with one of my QRP rigs, and I just got one of these little boards and fitted it in, and away it went. So something like that, or you can pick up, as I said earlier, a set of powered speakers from a computer, but you may find at a rally, or somebody's just thrown them out because they bought a better pair. Still useful to have. Okay, loudspeakers. Well, loudspeakers, they do go wrong, but remember, an 8 ohm loudspeaker is not going to measure 8 ohms. It's 8 ohms as its impedance. It's its AC resistance, effectively. So sticking a multimeter across it, you ain't going to measure 8 ohms. Now, if you stick a multimeter across the two terminals, one of the two things is going to happen to start with. Either the cone's going to jump forward, the cone of the speaker push forward, or it's going to be sucked back in, depending on which way round you put your multimeter and which is positive and which is negative. Yeah. If you leave that multimeter connected too long, the coil on the former will get hot and it'll distort. And then what happens is when the coil distorts, it rubs on the metal, the pole piece, as it's showing here. It rubs on the pole piece. And when it rubs on the pole piece, that's when you get distorted sound. Now you can work out if a speaker has been sort of, somebody's taken a 4-watt speaker and driven 20 watts through it, the coil's going to get hot. So if you take the speaker and you gently hold it in your hands and you just gently push the cone, it should bounce back out again, but you shouldn't hear any rubbing. If you hear a rubbing when you're pushing on the cone, then you've got a coil that's gone out of shape and is rubbing, and that's what's causing you distortion. So that's what I said. Multimeters, you can damage it. Distorted sound is often an off-center cone. Little tips on fault finding that. This circuit, it's a little Valmont circuit that used to produce about 1K, and then depending on which jumper you put in, you got a sine wave, a triangular wave, integrator, or a square wave, and I think these are about 10 quid. I think it's still available, but you can knock something up. There's loads of circuits online for little AF testers. It's not expensive. These come up at rallies quite regularly. They come up for about 25 quid. Just a RF generator. Get around. Now, dummy loads. We're all amateurs. Dummy loads have got to be carbon resistors, haven't they? No. They have for RF, and what we do, when we want to measure RF, we need carbon resistors, and that guy's made that one up with lots of 1K resistors in parallel and little circuit board. But think about it. Our dummy loads are not just for RF. If you was testing an audio amplifier, then you could replace that with a dummy load. That dummy load would be perfectly okay to be a wire-wound resistor, because after all, the coil in your speaker's a wire-wound device. And as I say, when I worked at Comet years ago, or in the 70s, the bench engineers used to have speakers on their deck bench, but they used to have power meters under them and a switch. And most of the time, because you don't want horrible, lots and lots of noise when they were testing power amplifiers, they'd use the power meter and feed them into dummy loads. So wire-wound resistors, that can be, but you can also use wire-wound resistors to load power supplies. You're working on the power supply. Yeah, if it's a DC power supply, it don't care whether there's no RF there anyway. It doesn't care, you know. So wire-wound resistors can be dummy loads, but not for RF. Okay, little simple circuit here for testing electrolytic capacitors. And I'll give Mike the circuit for this. But you put anywhere between 5 and 50 volts in, depending on the electrolytic you're testing. The most important device there is the little LED, and it's an indium galahide nitrate LED. These light up at phenomenally low current. So if there's any leakage, that little devil will light up. A normal LED wouldn't, but that one would light with very, very little current through it. The other diode across it is just to stop the back EMF when you disconnect, so you don't want to damage it. It just needs a diode across it for safety. But a little circuit, well worth, only going to cost you right about £1 or so for the bits, and you've got a capacitor leakage tester for electrolytics. Let's go back. Sorry, this one. If you are fault finding, now this one is AC coupled. You've got C1 and C2, so you're AC coupled. If it was DC coupled and they were just straight wires in with no capacitors there, don't ever do what I'm going to tell you next to do. But if you want to check that transistor quickly to see if that transistor is working in this particular circuit, put your multimeter on the collector and short the base emitter out. The collector then should go up almost to VCC. If it don't go up to VCC, it's a dead transistor. But once again, the caveat is you got to make sure it's AC coupled in the case like this one is with C1 and C2. I know it's a very simple circuit, but the concept is with all AC coupled transistors. It's just a quick and dirty way of checking. Now, oops, let me, okay, oops, come on. Okay, this one's jumped to show you everything, but I did this talk once, and Alan Betts from Bromley Club was in the audience, the guy who writes the training books, and he got up ready to pick a fight with me, and I said, I'll explain. Oscilloscopes have switched inputs. They can be used to measure AC or DC. When they're in AC mode, they have a serial capacitor, and I know I'm pretty much having to read what's on the screen here. They have a serial capacitor. This capacitor can become charged up. So you're poking around your circuit, and maybe on the 50 volts, you've got a 50 volt supply all around the output stage, and yeah, there's 50 volts there, 50 volts there. And then you go over to, say, an IC, and you look at the output coming out the IC. That's going to discharge that 50 volts into that IC. So if you are using an oscilloscope on AC, my suggestion is every time you make a measurement, take your measurement and then just touch the tip of the probe on ground, so you short away any AC before making your next measurement. That way you're not injecting high voltage into places where you shouldn't. Now, you don't want to damage transistors, because otherwise, you know, you might have one fault when you start. 10 minutes after you start and you're poking around with your oscilloscope, you might have half a dozen faults. And remember what I said, man-made faults are a pig to find. So, yeah, and they will probably no rhyme or reason to them why they're all that way. So why isn't there we go. Right, correct way to fit a capacitor. Okay, well, we all know electrolytic capacitors must be fitted the correct way round, otherwise damage will occur. There used to be a hole in my kitchen ceiling where I was fixing something for somebody, and he put an electrolytic in the wrong way round, and I was over top of this and looking, and I couldn't see, and I just turned around to grab something, and this capacitor went bang, and the metal case of the capacitor went up and punched a hole in my kitchen ceiling. I wasn't very popular with the XYL after that. Working in her kitchen is not always the best place to work these days, but safety, it could have got me right in the throat. But you know this sort of thing for safety, but the one which not everybody knows is non-electric capacitors have a right and a wrong way to be fitted. If they're fitted incorrectly, they don't perform as well. So look at the picture of this I drew. One end, there's a black line. Now this goes back in the early days. If you're renovating an old piece of valve equipment, you will often find, nearly always, a line or a marker on a wax type capacitor. Yeah, and what that's denoting is which end is the outside of the capacitor, because the capacitor is made of two plates. They wind them up together, and you've got an inner and an outer. We want the outer of the capacitor to go to either ground or to the lowest potential. If you put them the other way round, then the outer, it will inject hum and noise back into your circuit. So how do you find which way round? Well, there are one or two devices, but the easiest way, if you have an oscilloscope, put it across an oscilloscope, you clip the earth one side and the probe the other side, set the voltage quiet so you're looking for a low voltage, and then touch the capacitor. You will see the line on the capacitor open up. Then turn it around the other way and do it again. The one that opens up the most, when it opens up the most, your center probe is connected to the outer of the capacitor. So on modern capacitors that are not marked, you can find out which is the outer by using an oscilloscope and just injecting a bit of hum into it on you via your fingers across the capacitor. So the useful little tip if you're fitting modern capacitors into old equipment. Now, screws and screwdrivers. Has anybody come across a Japanese industry standard screwdriver? I wonder. Well, this is the one that every time I give this talk, people rush out and buy these because there's a Japanese industry standard screwdriver. Most people only think there's the Phillips or the Posi drive. So when you take a piece of one of your Japanese radios apart, you use a Phillips screwdriver and it appears to work. But often it manks the head of the screw. And I shouldn't tell you this, but if you take something apart and then you want to send it back under warranty, if you mank the screws, you've got no chance of warranty. But if you've got a Japanese industry screwdriver, it doesn't slip out and damage the head of the screw. And you can get stuff undone a lot easier. Now, they're not expensive. You can get a range of them, about 6 of them, various sizes and lengths, for about between 15 and 20 quid of Amazon as one of the places you can get them. And they're well worth it. Not just for radio. A number of us drive Japanese cars, have Japanese motorbikes. The Japanese use this standard screw across the Pacific Rim, so it's worth knowing that there is actually a third standard. The other one that, sometimes the screws have a dot, or the screw themselves has a dot on the head, which gives you a bit of a clue that it's a JIS screw head, but it's not always the case, so don't hold that as gospel. Refitting self-tapping screws. If you got your plastic box that you've made something and you put it in and you screw your first time, you screw your self-tapping screw into the screw hole. So you screw it down nice and tight. Then it doesn't work right, so you take the screw out. Well, if you screw it back in again and you take it out and screw it back in and take it out, well, after about 3 or 4 goes, there won't be nothing for the screw to connect to. You've wrecked the box. There is an easy way of doing it so you don't wreck the box and it becomes very easy to re-put the screws back in. Try it when you get next one you do, but take the self-tapping screw, sit it on top of the where it's got to go in, and just turn it anti-clockwise like you're undoing it. And when you turn it anti-clockwise, you will feel it go clonk, or you may hear a click, or you'll feel it drop, and it will drop into the thread it's cut the first time. And then you just screw it in without having to struggle. The screw goes in nice and easy, and it goes up tight. So the screw itself drops into the tap it's made originally by starting off by turning it anti-clockwise. Little tip, hopefully useful. This one got me just before Christmas. We all know about torque drives, don't we? Or do we? I'm showing the security ones. The ones on the left say hexagonal. They've got 6 points. That's the one you've all seen. I was working on a Bose speaker before Christmas, and the buggers had 5-point torques, and the ones on the right are 5 points. If you look at the T40, you'll see there's only 5 points on there. They're hexagon shaped. So I just mention it. There are such things. You may come across it. If you do, you just have to buy a set of torques like I did with a 5-point. But be aware, they're out there. What else we got? Another little thing I'd suggest if you're doing kit building or repairing printed circuit boards, a little PCB holder, third hand like this is well worth getting hold of. You just put it on your desk, you connect your PCB in between the two ends, and you can spin it round and do all sorts of things, and it makes your life easier. That's all. Static build-up on meters. Often analog meters will not zero, and the movement changes every time you touch it. So you go up to the front panel there and you touch it, and the meter moves. You think, oh, what the hell's wrong with this? Well, it's got a static build-up. Enter the very easy fix. Washing up liquid. Put a bit of washing up liquid on a cloth. Do not use water, but just wipe over the meter plastic case with a bit of washing up liquid and just polish it off, and you'll find that it'll take all the static off for you and your meter will work. I've sorted out a number of multimeters that way for people, and panel meters sometimes they get static build up on them. A little bit of washing up liquid does the world of good. Little circuit the Reverend George Dobbs came up with. I can't say I'm the good guy on this. You want to test a meter movement. You're at a rally. You want to test a meter movement. You want to know what value it is. Well, with those two resistors and a 1.5 volt battery, you can either make a meter move 1 milliamp or 50 microamps, which are the standards you're probably going to be looking at. Now, it's not 100% accurate, but at least it proves that the meter movement works, and you know the ballpark that the meter is going to be in. If, as I say here, it says plus 50 microamps and it goes fraction over 50 microamps, but it doesn't bang hard over, it's 50 microamps. If it measures 47 microamps, it's 50 microamps. It depends on the tolerance of the resistors you've got. But the Reverend George Dobbs, I published this once. I can't take any credit for it apart from telling you about it. And it's a useful little circuit to have. Little box you make up yourself. Okay, current on a multimeter. A lot of older multimeters, the old analog ones, which were low ohms per volt, there can be high currents when measuring resistance. So there's a good few milliamps going through them. Now, this may blow milliamp fuses when testing them. So if your multimeter is trying to shove 500 milliamps through a 300 milliamp fuse, it's going to blow, and you're going to think, oh, I've got a duff fuse, got a duff fuse, got a duff fuse. You've just blown them on your multimeter. So In comes the thing. This standard smartphone, you see a resistor sitting on the number 8. If you were to hold the top of that fuse and you put it on the number 8, the number 8 should display on the phone if the fuse is okay. If you put it on the phone and the number 8 doesn't show, then your fuse is blown. So it's a very useful way of testing fuses when you don't have a multimeter with you. You've gone to see a friend and they suddenly say, "Oh, my kettle don't work." Well, is the fuse blown or is the thing? But usually got your phone with you, so you can test fuses quickly. And it's a great way to test very low milliamp fuses without blowing them by using a standard mobile phone. Okay, removing components from lead-free solder. Oh, hateful stuff, this lead-free solder. I don't bother to unsolder them out of a printed circuit board because components, if it's got a damaged component, you're likely to damage the PCB and the tracks. And I remember having to change channel switches on walkie-talkies when I worked for one of the radio dealers. They got 9 pins on them and one thing and another, and we just used to, the icon radios, and we used to just cut the switch apart, break it apart, break it up in little bits, and then what you do is you safely remove the component leads because you broke the leads off and you pull the leads out one at a time, and it's much easier to heat a joint up and pull a pin out if you've cut the lead thing off. ICs work that way, but then you're left with a blocked hole. Now, hand solder pumps and braid, for the most time, are absolutely damn useless because lead-free solder solidifies at a very high temperature, and it used to frustrate the hell out of me. How are you going to do this? With lead solder, you can get away with your pump and the bits and pieces, but lead-free, it ain't going to work. So what do? Well, first thing you do, in a very simple way of unblocking the hole, is you put heat on the joint, and then when it's nice been on, put your solder on a joint, and then just tap it on the bench quickly. And what happens? Gravity takes over, your solder jumps out, and the hole's clean, and you're ready to put your new component in. Trust me, that's probably one of the easiest ways of getting lead-free solder out of a solder hole than messing around. If you start trying to push leads through and pins through holes and heating them up, it's horrible, but the gravity effect works very well. Right, not many more. Old valve equipment, most likely faults you're going to get if you're fixing an old piece of valve equipment. Watch out, you should change all the electrolytics if they're old. Wax capacitors, when I say wax capacitors, they're the wax and paper ones. Years ago, capacitors 2 plates, as we know, with a dielectric in it. They used to fit paper as the dielectric. Paper has gone acidic over the years, and it leaks DC through the capacitor. Not a lot, but enough to give you all sorts of problems, damaged valves, maybe other things. But wax capacitors, they're not worth testing. Just change the damn things. You can buy a very expensive capacitor tester. All it's going to tell you is to change it anyway. So if you're working on very old valve equipment, change all the electrolytes, change all the wax resistors. Check the resistors for value. Hum can be a short circuit between the heaters and the cathode. Usually heaters are AC, and you get 50 hertz hum if you've got a short between the heater and cathode in a valve. That can be a pain. Switches need cleaning and controls need cleaning. Alignment is last. The last thing you do, get the damn thing working before you start even considering aligning it. Because if you go in twiddling and think, oh, it just needs a little tweak, you're creating more problems and you're masking what the real problem is, and you're going to really end up having a bad day. But remember, this equipment runs on high voltage, so make sure you do it and you understand the risks. If you don't feel comfortable, don't do it. Okay, so most likely faults, low voltage stuff. Once again, electrolytic capacitors, they go faulty, they die. You can sometimes see them bulge at the top. They have a problem. The reason they bulge is that there's a thing called ESR, effective serial resistance. And when they're manufactured, there's a certain amount of resistance within the electrolytic can. Over time, that electrolytic resistance seems to increase. It's a manufacturing process. So you know if you've got a resistor and current flowing through it, it gets hot, it boils the electrolytic, and then they bulge at the top or they burst open at the top. That's what causes that. So they're worth changing. Tantalum capacitors, when they go short circuit, they go up in smoke. Years ago, I had an FT, I was given an FT 707. It was old at the time, but it worked and it was lovely. I had it for about a fortnight and then I switched it on and the PA went up in smoke. There was a massive cloud of smoke come out of the PA and I left it for about 3 months. I thought, oh God, this is really going to be something. Eventually took it apart, had a look inside, and Yaesu put a tantalum capacitor straight across the 12-volt line or 13.8-volt line. And this tantalum capacitor had gone short circuit. Well, there was no current limiting on it, so it just went up like a Roman candle. And I took the tantalum capacitor out, put another one in, the radio worked perfectly. In fact, it happened a couple of times on that one, so that radio, don't own it anymore. Resistors do change in value. Sometimes they go up, sometimes they go down. If a capacitor changes in value, if you've got a capacitor meter and you measure it and you say, oh, it's supposed to be a 0.1 microfarad capacitor and it's measuring 0.22 or 0.4, it's not an overachieving capacitor. It's leaking. It's leaking. These capacitor testers work on how long it takes to charge up, and they work out the value from that. So if it's right, I've got things going off in my shack here. Not much longer to go. Interconnecting leads, dead semiconductors, cleaning switches, lastly alignment. And that, mate, is the end. Any questions?